Okay, the first part of the review is where you're basically just naming things, and on the test, these will either be multiple choice or they will have drop down boxes for you to choose from. So there's not necessarily any work to show. And I went ahead and to keep this video a little bit shorter, I went ahead and wrote in the answers for the first ones, and then I will actually work through the ones where you have to start showing work. So question number 1, the difference between a population and a sample. Population consists of all outcomes that are of interest. So all outcomes, all measures, all people that were surveyed, everybody that is of interest for that particular experiment or that particular observation. A sample would only include part of or a subset of the population. On question 2 and 3, you're just determining whether it's a population or a sample. 2 says a survey of 300 people from an auditorium with 13,000. So this is a sample since it's a subset of the 13,000. And number 3, the annual review of each store in a shopping mall. This would be a population because it says each store. So since it includes every store in that mall, it includes all of the stores of interest. So it is population. Number 4, the difference between a parameter and a statistic. A parameter is a numerical description of a population characteristic, and a statistic is a numerical description of a sample characteristic. So here you would be looking to see, for parameter, you'd be looking for population. For statistic, you would be looking for sample. And that's what the next 2 questions ask. Determine whether it's a parameter or a statistic. On number 5, the average salary for 45 of a consulting firm's 300 engineers is $72,000. And this would be a statistic because it's showing the salaries of only a sample of the 300 engineers. And then on number 6, it's 62% of the governors of the 50 states. So this is a parameter because it's a description of the population of all governors. So since it's the governors of all 50 states, that's a parameter because it's a population. And that's what you'll be looking for in your answer choices. It will list statistic and give a reason, or parameter and give a reason. So you're always looking for statistic to have something in there about a sample, and parameter to have something in there about the population. Next is qualitative and quantitative. The weights of dogs would be quantitative because weights are numerical measurements. The species of mammals in a rainforest would be qualitative because that's just a label or a characteristic. It's not a number. The level of measurement, remember on the level of measurement, your levels were nominal, ordinal, interval, and ratio, and that's going from the lowest level to the highest level. On number 9, it's just giving the regions representing the top salespeople. This would definitely be nominal because there's no mathematical computations that can be made. On number 10, it's giving the top 10 teams in the final college football poll, and they are listed in order. So this would be ordinal, since the data are arranged in order, but finding differences would not necessarily be meaningful. The next thing we look at is the difference between an observational study and an experiment. On number 11, it says that 51% said the U.S. president should release all medical information that might affect their ability to serve. This is definitely an observational study because it was just a survey, and they didn't receive any kind of treatment or anything to influence their answer. On number 12, researchers demonstrated the adults using an intensive program to lower blood pressure to less than 120 millimeters of mercury reduced the risk of death from all causes by 27%. So this is an experiment because they were using an intensive program to lower the blood pressure. So since they were applying a treatment, and the treatment being the program, then this is an experiment. On number 13, they're wanting you to analyze an experiment. So if you read through the question or the experiment that's being conducted, on A, they want you to identify the experimental units and treatments. The experimental units would be the 500 females aged 25 to 45 who suffer from migraines. And then the treatment is that they are testing out a new drug used to treat migraine headaches. So your treatment would be the new drug. A potential problem here is that they only used females who were aged 25 to 45. So the study didn't include males. It didn't include any people younger or older than the 25 to 45. So the group might not have been representative of the entire population. Another potential problem would be if the researcher knew which patients were receiving the drug and which ones were receiving the placebo. So to make it a double-blind study, which is what they're asking on 3, neither the patients nor the researcher knows who receives the drug and who receives the placebo. There would be a third party involved that would have a record of who was getting which treatment. Next is the sampling techniques, and there were several sampling techniques listed in section 1.3. So this is 3 of the examples, but you would need to go back and look in section 1.3 and look at all the different sampling techniques. I just included 3 here on the review. Questioning university students as they leave a fraternity party. A researcher asked 463 students about their study habits. So this would definitely be a convenient sampling because the researcher is only questioning students who are leaving a certain place, in this case, the fraternity party, so it's convenient to ask them as they leave. A potential source would be the students at the party might not be representative of all the students, and this could also be a question that students might not answer truthfully. On 15, after a hurricane, the disaster area is divided into 200 equal grids, and 30 of the grids are selected, and every occupied household is interviewed. This is called cluster sampling because they're divided into grids, and some of the grids are included, and everyone in that grid is included. That's called a cluster sampling. Some potential source of bias would be that some of the grids might have been more heavily damaged than other. So that wouldn't necessarily, those in the more heavily damaged areas might need different requirements than the others. So that would be a potential source of bias. Or if it was extremely heavily damaged, those households might not even be occupied, so they wouldn't be getting results from everybody. On number 16, every 10th person entering a mall is asked to name his or her favorite store. Since they're standing there and getting every 10th person, that's called systematic sampling. Bias could be only if maybe you were only there in the morning, so you were only getting a certain group of people, if there was some kind of pattern to when they entered the mall. So for example, if you were there on a school day and you were there in the morning, you might only be getting older people or retired people. You wouldn't be getting students, so that might affect how they answered what their favorite store was. And then another one would be if you limited the number of choices and you just gave them a list of maybe 5 stores, then that could be the question itself could limit their answer choices. That could be a bias. Okay, we're moving into, this is the information from chapter 2 now. So these are where we're actually having to work out some problems and do some math. This is where I will start looking for you to show your work on paper for 2 reasons. One reason is you have to show your work in order to get credit for the problems. And then the second reason, and maybe more importantly to you, is if you work it partially correct, but just enter your answer wrong, then I can give you partial credit for it. So as I move through these, the work that I'm showing you and explaining, that's what I'll be expecting to see on your paper. On number 17, it's just asking you to create a stem and leaf plot. So on this, we have, first thing you want to do is you want to find the smallest number, and then you want to find the largest number so that you can figure out how many stems you're going to need. So it looks like our smallest number is 24 and our largest number is 50. So we will need stems of 2, 3, 4, and 5. And then you just start putting the numbers in. So there would be our 24, and it looks like we have 130, and I'm just kind of marking them out as I go to help keep up with which ones we've already done. And then it looks like we have 1, 2, 2 32s. Then we have a 33. It looks like we have 2 35s. You notice when you put these in here, you're just putting the leaf over here, which is the number, the ones place of the 30s numbers. And then we have 1, 2, 3, 4 36s. 2 38s and a 39. And then moving to the 40s, we have 1, 2, 3, 4, 5, 6, 7, 8 40s. So that means we'll put 8 zeros across here. And then we have a 48. And then we have the 50. And after you've constructed it, then you need to make a key or show what the key is. So just out to the side somewhere, you would have that the key is, and you can use any number from the stem and leaf plot you want to. I'm just going to use the first one. The 2 and then separated from the 4 would be the same thing as 24. And that's constructing the stem and leaf plot. You could do some interpretations here. Obviously, the vast majority of nurses get between 30 and looks like most of them get between 30 and 40 hours, or you could even say between 30 and 48 hours. But that would be an interpretation you could make from looking at the stem and leaf plot. Next, we're constructing a pie chart. On the pie chart, you have to do a couple of things before you start working within the circle. The first thing is you need to get the total number of people involved in the study. And so what we would do is we would add up the number of degrees, all 4 types of degrees, and that would come out to 3,805. And then after you add that up, you would go for each one. So we'd start with the associates, and you would do the number of associates out of the total number and get a decimal value, which would be like your percentage. So that would come to 0.264. So that would be 26.4% received associate's degree. To figure out how much of the circle that takes up, circle has 360 degrees. So we do that decimal times 360, and that gives us a 95-degree angle. And then we'll do the same thing for each of the others. So for bachelors, we would have 1870 out of 3805. That would give us 0.491. We'd multiply that by the 360, would give us a 177-degree angle. And then we have the masters is 754 out of 3805. Gives us a decimal amount of 0.198. Multiplied by 360 would be 71 degrees. And then finally the doctoral would be 178 out of 3805, which would be 0.047. Multiplied by the 360 would give me a 17-degree angle. So we'll come over here, and I always start with the largest one because to me that's the easiest one to start with. 177 degrees is almost half the circle. So if you kind of go here in the middle, and it really doesn't matter which way you go with it, I'm just going to go straight across here. So if I went straight across, that would be 180, which would be half the circle. So I'm going to go just a little bit less than straight across. And then what you would do is you would write inside here, bachelor's, and then you would write the percentage, which was 49.1%. And then we would do the same thing. I'm going to make this a little bit bigger so I have room to, can write in it easier. The next one was the 95 degrees, which was the associates. So 95 degrees is exactly a fourth, or 90 degrees is exactly a fourth. So I'm going to go just a little bit bigger than a fourth of the circle. And then I'm going to write in here associates. And then that was 26.4 degrees. And then 71% would be, and you're just kind of estimating here. And of course, they will have some pictures already drawn from you. You're not going to have to create these yourself on the test, but you will need to on your paper. The 71 degrees is the masters. So we would write masters in here, and that's 19.8%. And then finally, the little sliver that we have left is this 17 degrees. And if you don't have room to write in, you can just draw an arrow. And this would be the doctoral. And that was only 4.7%. And that's how you create your pie chart. Okay, next they're asking us to construct a frequency distribution with 5 classes. And so on here I included a table to organize the information a little bit. So when you're constructing the frequency distribution, the first thing you want to do is find the max and the min, and because this is going to help us to figure out the class width. So you're going to be for class width, it's going to be the maximum number minus the minimum number divided by the number of classes. And they will always tell you how many classes they want you to use. So on this one, the maximum number is 39 and the minimum number is 0. So 39 minus 0, and they wanted 5 classes. So 39 minus 0 is 39, divided by 5 is 7.8. And you always round up. Even if this were a whole number, you would still round up to the next one. And I know that was one of the questions that some people had on one of the homework questions. So even if this came out to 8, you would have to round up to 9. So in this case, 7.8, it's going to round up to 8. So that's your class width. So the way you create your classes, start with the minimum number, and then you're going to go down and you're adding 8 to get the beginning of the next class. That 8's not going to be the end of the first class or the upper limit of the first class. It's going to be the lower limit of the next class. So you're adding 8 here. So add 8 each time until you have your 5 classes. And then the upper limit has to be 1 less than the start of the next class. So since this is 8, this would have to go up to 7. And then since this is 16, that would have to go through 15. So this one would have to go through 23, through 31, and you add 8 over here, 0 plus 8 to get to 8, and then plus 8 to get to 16. You're doing the same thing on the upper limits. 7 plus 8 is 15. 15 plus 8, 23 plus 8, so 31 plus 8 would be 39. And when you get there, you should have enough classes to include everything from your minimum to your maximum. And the last one may go a little bit above the max, and that's okay. You just want to make sure they're all included. Now we're going to look at the frequency. So how many of the numbers fall between 0 and 7? So you can mark these off as you go. So there would be 1, 2, 3, 4, 5, 6, 7, 8. 8 of the numbers fall between 0 and 7. Between 8 and 15. So you would count all the numbers from 8 to 15. So 1, 2, 3, 4, 5, 6, 7. So 7 of them fall between 8 and 15. And then just do the same thing for each of the next groups. So 16 to 23 would be 3. 24 to 31 would be 3. And 32 to 39 would be 3. And you can just do that by counting up here. Okay, for the midpoint, you're going to add the lower limit plus the upper limit of the class and divide by 2. So 7 divided by 2 would be 3.5. And then here you would do 8 plus 15 divided by 2. So that would be 23 divided by 2, which would be 11.5. And then do the same thing all the way down. So this one comes out to 19.5, 27.5, and 35.5. And another thing with the midpoints is they are also going to be 8 apart. So just like your classes, the lower limits are 8 apart, the upper limits are 8 apart, so are your midpoints. So once you find that first midpoint, you can add 8 each time to get the other midpoints. On the relative frequency, that will be the number of times that occurs out of the total number. So down here, we're going to want to find the sum of all of the entries or all of the frequencies. So if you add these up, or you can just go back and add up and see how many, count up how many entries there are. So there were 24 entries. But that's a good way to make sure you've included all of them here, is to make sure you add up all these numbers and it comes to 24. So your relative frequency is the number of times it occurs out of the total. So this first one, 0 to 7, would be 8 out of the 24, and that's 0.33. And then the next one would be 7 out of 24, and that would be 0.29. And you can just get these numbers from your calculator. And then 3 out of 24 would be 0.13, and these other ones are also 3, so those would all be 0.13. The cumulative frequency starts with the first class frequency, which is 8, and then you add up the rest of them. So from 0 to 7 is 8. From 0 to 15 would be 8 plus 7, which is 15. From 0 to 23, going from here to here, would be 8 plus 7 plus 3. So I'd add another 3 and get 18. And then up to 31 would add another 3 and get 21. And then up to 39 would add another 3 and get 24. And when you get that, you should end up with the total number of entries, which is 24. Okay, for your class boundaries, you don't want there to be a gap between 7 and 8 and between 15 and 16. So because even though these aren't, but if in case you had data entries that were like 0.5 or 0.6, you would want every data entry to be included. So what you do is you go 0.5 below and above each of the lower and upper limit. Now, since this one is 0, I'm not going to go below 0 since all my entries are positive. So I'm going to leave that one at 0, but I would need to bring that up to 7.5. And then the next one would start at 7.5. So that would be 0.5 below the 8 and go up to 15.5, which would be 0.5 above the 15. And then the 15.5 goes down to the next one, and then do the same thing. So this would go up to 23.5. This would start at 23.5 and go up to 31.5. And then this one would start at 31.5 and go up to 39.5. And that's how you create the class boundaries. And that ensures that there's not a gap between the entries. Okay, to create the relative frequency histogram, now you can create a frequency histogram, which would just include how many of each entry there are, and then within the classes. And then you could create a relative frequency, which does the percentages, and that's the one we're going to do is the relative frequency. Okay, on these, we're going to use the midpoints. Instead of writing 0 to 7 and 8 to 15, we're going to use the midpoints as our labels. So we'll come down here and we'll have our midpoints were 3.5, 8.5, or 11.5, 19.5, 27.5, and 35.5. And then the relative frequencies were anywhere from 0.13 to 0.33. So I'm going to go up here and I'm going to make this 0.10, 0.20, 0.30, and 0.40. And then, of course, these would be labeled. I'm not taking the time to label these. This down here would be your cumulative frequency, and this would be the, these down here would be the midpoints, and then this to the side would be the relative frequencies. All right, so what you do to create the histogram is you're going to have bars, and the bars will be connected. So we'll start about midways between 0 and the 3.5, and then we'll go about midways between the 3.5 and the 11.5. And we're looking at the relative frequency, so 0.33. So we're going to come up here, come just below where the 35 would be, and we're going to draw our bar. We do not, our bar doesn't go all the way over to the 0. So we start a little, that's why I started kind of in the middle. And we draw that bar and it gets shaded in. And then the next bar will connect to this. So the 11.5 midpoint was 0.29%. So that means we're going to go just here, just below the 30%. Draw our bar. And then the next one at the 19.5, that was at 0.13. So we'd go just below the 15 here. And then the next three are actually the same. These were all 0.13. So we would have 3 bars all at the same height. And those would be shaded in. And that would be your relative frequency histogram created using the midpoints. On number 20, we're going to do a time series chart. And for your time series chart, these are just going to be plotted points, and then you can look at it and see if you can determine any patterns or trends. So this was 2008 through 2015. So you could show here that we're going to do a little break in the graph and start at 2008. And then we're just going to go up each year until we get to 2015. Okay, on the other one, we're starting at, looks like the lowest one is 74.2. So again, we could indicate that there's a small break here. We're not starting at 0. And we could make this first one here, I'm going to skip up a little bit. We can make this first one 70. And then 75, 80, 85, 90, 95, 100, 105, 110. And it looks like the largest number is 106, so that'll be high enough. And then all you're going to do is put a dot or a point where that pairs up the year or the time with the number. So on this one, it shows that we have in 2008, there were 74.2, and this is in thousands. So you would have over here labeled, of course, if you labeled this, this would be the year across the bottom here, and down the side, it would be the number of degrees in thousands would be labeled. And we want in 2008, 74.2. So that would be a little bit below the 75 mark. And then 74.4 would go up just slightly. and then those would be connected. You connect these as you go. And then in 2010, 78.3. In 2011, 83. 2012, 88.2. 2013, 93.4. 2014, 99.2. And then in 2015, 106.7. And then it says to describe any patterns. Well, it definitely looks like that the number of degrees being conferred is increasing over this time period. So you could just write that the number of degrees has increased from 2008 to 2015. So that's an easy trend to see on that one because it is definitely going upward. Okay, on number 21, they're asking you to display the data below in a Pareto chart. So on these, what happens is it's like a bar graph to a certain extent. It's not like the frequency histogram because the bars are not connected. And the way you create this is you go from the highest to the lowest. So when you look here, you're going to we have 4 categories. So we know that this is going to be divided up just into 4 categories. And we have fall is the greatest. Spring and summer are equal here. So you can just do that alphabetically. Spring would come before summer. Since they're equal, it doesn't really matter which one goes first. And then winter is the smallest. So on these charts, you always put whichever one occurs the most first, and then you go down to the one that occurs the least. And then on the side, you do your percentage. So across the bottom here would be your seasons, and going up the side would be the percentages. And we need to go all the way from 8% up to 40%. So I would count by fives. So we would have 5, 10, 15, 20, 25, 30, 35, 40, and you can just label every other one. Or if you want to, you can label every one. And then you're going to create a bar around the fall that goes up to 40%. So you don't want it to go all the way over. You want it to just kind of be have fall centered. And then we go to spring, and it's not going to be connected, so you're going to skip over and kind of center it. It's at 26%. And then summer's also at 26%. And then winter is at 8%. And that is your Pareto chart. Notice that goes from the tallest to the lowest, highest to lowest, and that's how that will always be created. On 22, just identify the shape of the distribution. When they're all the same, all the way across, that is called a uniform distribution. If you have what they call a tail on the right side, so you can see that your data it comes to the highest point, and then it kind of trails off and goes to a little tail over here. That is called skewed right. When all the information is pretty much evenly situated so that it's kind of the same on either side. So if it's the same on either side, that's symmetry. So that would be a symmetric distribution. And over here, your tail is kind of to the left side. So this one would be skewed left. Next, we want to find the mean, median, and mode. And then if any of these measures do not represent the center, explain why. So first thing I'm going to do is find the mean. And for the mean, these are a sample of the 7 students. So remember, our symbol for sample mean is X bar. You're just going to add up the numbers. And you're going to divide by the number of people included in the sample. So the formula I'm using here, which you'll want to have written on your formula card, is the sum of the X values, or the entries, divided by the number in the sample. So when you add these up, you get 1,205 divided by 7, and that's approximately 172.1. For the median, we have to put the numbers in order from least to greatest. So 169 is the smallest. So 169, 169, and then 170, 172, 174, 175, and 176. And the median is the middle number. So since there's an odd number, it's the one right in the middle. Remember, if there's an even number, you take the 2 in the middle and find the average. But on this one, the median would be 172. And then the mode is the one that occurs the most. The only one that occurs more than once is 169. And this would not represent the center. And that's because the 169 is actually the lowest or the smallest of the numbers in the set. So it's definitely not one of the center. It's not the center of the data. So it does not represent the center because it is the smallest number. Huh? 172 is definitely in the middle, and the mean was 172.1, which is definitely in the kind of in the center, in the middle. Next is finding weighted means on number 24. To find the weighted mean, you multiply the number or the entry by the number of times it occurs, or in this case, it's by a percentage. So on this one, we have the score of 85, which is your homework, gets 5% of is 5% of your final grade. Quizzes will be 35% of your final grade. So what you're going to do is you're going to multiply the X entries by their weights. So we would have 85 multiplied by 0.05. Remember, when you use a percentage, you move the decimal back twice. Change it into a decimal number before you do any operations. So that would come out to 4.25. And then 80 would be multiplied by 0.35. 100 by 0.35. And then 93 by 0.25. And the way you find the weighted mean is you do the sum of X times W, and you divide it by the sum of the weights. So if you add up these numbers, you get 90.5. And if you add up the weights in decimal form, that would come out to 1, which it should because it's 100%. Your 5%, 35, 35, and 25, that's 100% of your grade, so that should come out to 1. So this would be 90.5 divided by 1, which would be 90.5. And again, the work that I'm showing on each of these problems, that's the type of written work I will expect to see when you submit your written work.